We are going to start chapter 2, summarizing and graphing data. So how many of y'all can empathize with this? Use of the last 12 hours before your 15-page paper is due. So if there were colors on here, which one do you think matches with the biggest portion? Facebook. Yeah. Crying because you're going to fail, skimming your research notes, inserting huge quote boxes, making a cover page, making the margins really small, and then writing. All right, so let's go ahead and we are going to look at different kinds of graphs within this chapter. So we're going to start with 2.1. So characteristics of data. We have the center. Center is a representative value that indicates where the middle of the data are. So we're going to talk about the center a lot. And there's different ways of finding the center. There's mean, median, and mode. Those are options. Variation is a new word. It measures the amount that the data is varying among itself. The measure of the amount that the data values vary among themselves. So how far apart are they? How close together are they? That's your variation. Distribution is the nature or shape of the spread of the data. We're going to look at the distribution. How is the data spread apart, really close together? What does the shape look like? Then we have outliers, sample values that lie very far away from the vast majority of the other sample values. It's important to note which ones are outliers because sometimes we can take them out of the data and only look at the values that are closer together, not those crazy outliers that may not represent that sample data. Time is changing characteristics of the data over time. So whenever we look at data, we are going to look at these things: center, variation, distribution, outliers, and time. So it's not as important to crunch the numbers. So we'll use technology instead and make practical use of the data through critical thinking. However, you will learn the manual calculations so you gain deeper understanding and a better appreciation for the technology used. We have different ways of using technology. We can use what's called StatCrunch. We can use Excel. And we can use our calculator. So we'll use all throughout the semester. So the first kind of graph we're going to look at is a frequency distribution, which is also called a frequency table. Lists data values along with their corresponding frequencies or counts. We have lower class limits, which are the smallest numbers that can belong to the different classes. Then we have upper class limits. It's the largest numbers that can belong to the different classes. Class boundaries, the numbers used to separate classes, but without the gaps created by your class limits. Then we have the midpoint, class midpoints. Midpoint, the middle. So the values in the middle of the classes found by adding the lower class limit to the upper class limit and dividing by 2. So you can find your midpoint for that class. So you'll have the lower plus the upper, and then divide by 2 to find your class midpoints. Then we have the class width. This is the difference between 2 consecutive lower class boundaries. We're going to look at what each one is on an actual example of a frequency distribution chart. The range is difference between the lower and the upper limits. All right, so we have all this vocab, and it's really hard to understand because we don't have context yet. So we are going to look at, I'm going to kind of look at these together so I can go back and forth between the definition and what it actually is. So our classes. So this is what a frequency chart looks like, frequency distribution. So we have classes. So this is a sample of data. We're looking at a sample of data. So any of the data values that are between 1 and 5 would be tallied here. So there are 5 data values between 1 and 5. 8 data values between 6 and 10. 6 between 11 and 15, and so on. So these are called your classes. So it says identify the classes. These are your classes. So we have 1, 2, 3, 4, 5, 6 classes. We need the lower class limit. Well, it gives us right here. What are the classes? Classes are 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and 26 to 30. Those are the 6 classes. The lower class limits are the smaller of the number of those classes. So for 1 to 5, our lower class limit would be 1. For this one, it'd be 6. For this class, it'd be 11. For this class, it'd be 16. For this one, it'd be 21. And for this one, it'd be 26. And so then the upper would be the top value, or, the one on the right. So we have 5, 10, 15, 20, 25, and 30. So these are your upper class limits. The class width is the difference between your 2 consecutive lower class boundaries. So from 1 to 6, from 6 to 11, from 11 to 16, 16 to 21, 21 to 26. So our class width is 5. So you could subtract them. So this was found by doing 6 minus 1. Or 11 minus 6. Your range is actually between the lower and the upper limits. So what we want to actually find for our range is we want to do the smallest lower. Largest upper minus the smallest lower. That'll get your range. Largest upper minus the smallest lower boundaries. So whenever I go over here, this 1 is my smallest lower, and 30 is my largest upper. So for my range, I would do 30 minus 1, and that'll give us 29. Okay, let's see. What else did we not find? Class boundaries, the number used to separate, we're going to get to that. And then the class midpoints, we'll get to that too. So let's look at the guidelines for constructing a frequency distribution from a data set. Determine the amount of classes you're going to make. So somewhere between 5 to 20. In our example, though, the one that we're about to do, we're only going to do 3 classes. But usually we want them between 5 and 20. Then you're going to find the class width. So our class width was 5 here. So 5 between each one of your lower class limits. And then you're going to divide it by the range. Divide the range of the data by the number of classes and round up. Then we're going to find the class limits. We're going to use our minimum value for the lower limit of the first class. So in our example above, that was 1. 1 was the minimum, so that was our lower class limit for our first class. And then you're going to add the class width to the lower limit to find the lower limit of your next class. And then repeat until you get all of your classes. Once you get all your lowers, then you can write all of your upper limits. And this seems kind of foreign at first, but we're going to do an example after we write these. Use tally marks for each data entry to determine how many data entries fall in each class. And then count up your tallies to find the frequencies for each class. Okay, let's look at our first one that we're going to do. So on this one, they gave us how many classes, because if you look, we have 1, 2, 3 classes. So we didn't actually get to decide on this. So state the number of classes. We're going to do 3. So we have to find, let's answer these questions. Number of classes is 3. Let's look at what this data is all about anyway. Construct a frequency distribution that has 3 classes for the age at inauguration of the first 30 presidents of the United States. Okay. So now we need the minimum data entry. So look through all the numbers. What's our minimum? Yeah. I'm going to go ahead and label it and write it out here. Then we need our maximum. Yep, 68. Okay, so we did step 1. We found our min and max. Now we need our class width. So let's look at how did we find our class width? the difference between the two consecutive lower class boundaries. So the way that's found is divide the range by the number of classes. So what's our range? We need to find our range. 68 minus 42. So it'd be 24, 26, 26. And then we're going to divide that by our number of classes. So we take 26, divide by 3. So 8.6 repeating. And it does say round up. So we're going to round up to 9. So that's our class width. So we found those. And now find the class limits. So we want the lower class limit first. The lower class limit for the first one comes from our very first data point, which is our minimum. So that'll be 42. And then from 42, we go to find our next lower class limit by adding our width. So we're going to do, I'm going to do like this, plus 9 to get 51. And then do it again. Add plus 9 here. So that's going to be 60. So those are my lower class limits. And then your upper class limits are going to just be the one right before this. So if our lower is 51 for the next class, our upper would be 50. So this lower is 60. So the upper from the one right before it would be 59. So what's included between each one of these? It'd be 8, right? 42 plus 8 gives us 50. 51 plus 8 gives us 59. 60 plus 8 will give us 68. So finding the classes takes the longest amount of time. And now we're going to do some tally marks. So let's do all the data between 42 and 50. Well, we could just really go through and let's say 57 would be right here. So I'm going to mark it off and put a tally. 61, 57, 57, 58, 57, 61, 54, 68, 51, 49, 64, 50, 48, 65, 52, 56, 46, 54, 49, 50, 47, 55, 55 again, 54, 42, 51, 56, 55, and 51. Counted something twice. 51 should have gone here, that last one. Okay. So now that I have the tallies, now I can write what the frequency is. So that'd be 8, 17, and 5. And then it says summation of F. Do y'all recognize this symbol? That means the sum of the frequencies. So we'd need to add those up just to double check that we did all of those data points. And it should equal 30 because we got data from 30. Okay, additional features of our standard frequency distribution. Our midpoint is going to be found by doing, let's write our formula, the lower limit plus our upper limit divided by 2. Our relative frequency, relative means in relation to others. So the way that you can compare is you can look at percentages. So relative frequency is going to be your class frequency divided by your sample size. So for our 30 presidents, we would need to divide 8 by 30 to find our relative frequency. Our cumulative is the sum of the frequencies of all classes, of a class and its previous, and all previous classes. So cumulative means you're adding as you go. Relative means we're dealing with percentages. So it's going to be a percent. Or a decimal. That could be switched over to a percent. So we're going to use the 30 U.S. presidents to complete this table. So we already have classes, so let's just copy those down. So 42 to 50 was 8. 51 to 59 was 17. 60 to 68 was 5. And the sum of the frequencies was all of our data values, which came up to be 30 when you add those together. So we need to find our midpoint. So midpoint is lower class limit plus upper class limit divided by 2. So you're finding the middle between 42 and 50. So you can add those up and divide by 2 or just do it in your head. It's up to you. So that would come out to 46 on your midpoint on that first one. And then we have 51 plus 59 divided by 2. Come out to 55. And then 60 plus 68 divided by 2, 64. So those are our midpoints. Relative frequency, this is where we're going to get the portion of total. So we are going to use our frequency and divide by our sample size. So our sample size is 30. So 8 divided by 30. So it's 0.2, we're going to round, 27. And then our next one is 17 out of the 30. 0.57. And then 5 out of the 30. 17. And together, what should they add up to equal? A whole, or 1. And the reason it's 0.01 is because we rounded. But we are going to put 1, which is going to be 100%. I guess I should put little squigglies to show that that's not exact. There we go. So that's our relative frequency. We're comparing it to the rest of them. So the largest portion would be the 51 to 59. So under patterns, that's what we can put. So that's majority of those U.S. presidents were between 51 and 59, ages between 51 and 59. Okay, cumulative frequency is where you take your class and then you add it to the previous. So our first class had 8. And then cumulative means I'm going to do 8 plus what we currently have, which is that 17, which is 25. So all of the presidents that are between 42 and 59 would be 25. And then the last one would be all of them, because then you would add what you previously had, the 25, plus your current class, which is 5, giving us 30. So when you do a cumulative, this should equal your total sample size, because you're adding them as you go. Interpreting a frequency distribution. So we need to know how to find them, how to create them, but also how to analyze them. So characteristics of normal distribution include bell-shaped. So bell-shaped frequencies start low, increase to some maximum frequency, and then decrease to a low frequency. So start low, go up, and then come back down. And it's approximately symmetric, meaning frequencies are symmetrically distributed on both sides of the max frequency. So if they are a normal distribution, they will be these two things. Bell-shaped, which when we get to actually doing histograms and stuff, it's going to look like this. That's what your bell-shaped normal distribution looks like. And if you were to cut it down the middle, they're about the same on both sides. They're symmetrical, about some middle value. So let's complete the following frequency distribution so that there are 21 sample values that make up a normal distribution. So look at our values. So we have 20 to 24 has a frequency of 2, 25 to 29 is 5, 30 to 34 is 7, 35 to 39 is something, and then 40 to 44 is 2. So see how it starts low? Where would our max be between what two values? Yeah, so on the frequency it'd be 5 and 7. So 7 looks like it might be the maximum. So we need to check and see. It says that there's supposed to be 21. So we're missing 1 though. So why don't we add this and see what's going to go here. So 2 plus 5 plus 7 plus 2 more. It'd be 16, right? So then how many are missing? How many values? So 5 missing. So that means that it has to go here. So do you see how it's symmetrical now? If we start at the top and the bottom, 2, 2, 5, 5, so 7. So the maximum is going to be 7, a frequency, there's 7 in that one, between 30 and 34. So this starts low, goes up to some maximum, then comes back down. Let's look at the next one. So this includes different numbers, and we have 2 question marks here. Go ahead and look at it. This time we have 30 sample values. So the 3 is low. The 3 down here is low. Then it gradually goes up. So whenever you add these up, what do we get? 16? And 30 minus the 16. So there's 14 missing values. So where are those values going to go? We're going to split them between those 2. So 7 will go here and 7 will go there. So that means that this is our max. It's split between those 2. The presence of gaps in the data. So these don't have any gaps in the data. Suggests that there are from 2 or more different populations. So if we look at this, see how there's gaps in the data? So this is talking about weight in grams of a penny. So we have this data, and then a big old gap, and then this data. So whenever you have gaps like that, that may suggest that you have 2 different populations. So what it tells us here is it was discovered that pennies made before 1983 are 97% copper and 3% zinc. And after 1983, they're 3% copper and 97% zinc. So that accounts for how they weigh differently. So that is it for 2.1. So your assignment is on Pearson.